Hey, Math 20-2. Today we're going to look at lesson 1 of reasoning with angles and triangles. We're going to do a little investigating angle relationships review. So, you want to have a protractor and a ruler with you. If you haven't got one, you can get one from the teacher. Types of angles. Draw an appropriate arc to represent the angle x degrees in each case. For the figure which represents a right angle, use this symbol. So an acute angle where x is greater than 0 but less than 90 degrees, that's this diagram here. So there's our arc, that's x degrees. So that angle is between 0 and 90, that's called an acute angle. A right angle of 90 degrees is right there. An obtuse angle where x is greater than 90 but less than 180, this would be the definition of an obtuse angle, that's x degrees. A straight angle looks something like that. Right, that angle is 180 degrees. A reflex angle where x is greater than, they're missing the number 1, 180, but less than 360, that's this angle here. So that angle is greater than 180 but less than 360, x degrees. And a complete rotation, a 360 degree angle would look something like that. So that's 360 degrees. Stops where it started. All right. Angles on one side of a straight line. In each case, use a protractor to measure the indicated angles and complete the work. So here we've got our protractor. Let's measure the indicated angles. If we can't see that well enough. It looks to be, you put that right in the middle, right on the vertex of the angle. So now it looks to me like angle X is from 0 all the way to 140. So angle X is 140 degrees, and angle Y is 0 to 40, so Y is 40 degrees. So if you add those two up, we get 180 degrees. Let's see if we put this on this shape. And now let's rotate him to there. Very nice. And now it looks like angle A starts at 0 and it goes to about 120. And angle B starts at 0 here and it goes to, in this direction, it goes to 60 degrees. So 120 plus 60 is 180. And let's try it over here with the last one. Angles P, Q, and R. All right, so angle P looks to be about there we go. Angle P, if we go from here to there, looks to be about 35 degrees. Angle R, if we go from here to there, that looks to be about, let's just extend this so you can read that. That looks to be about 55 degrees. All right. And now if I want to measure angle Q, let's just turn this. And it looks like angle Q is exactly 90 degrees. All right. So angle Q is 90. So you add those all up, you get 180 degrees. Hey, so if we use inductive reasoning, angles on one side of a straight line. Angles on one side of a straight line seem to add up to 180, 180, 180, 180 degrees. All right. Two angles which add up to 180 degrees are called supplementary angles. Each is a supplement of the other. In part A above, x and y are called supplementary angles. X is a supplement of y, and y is the supplement of x. All right. Example 1, calculate the angles marked with the following letters. Well, I know that along a straight line, this has to add up to 180. So if this angle is 155, then A should equal 180 minus 155. So A is 25 degrees. I know that in part B here, all the way along here should add up to 180. So I've got 51 degrees plus 68 plus B. So 180 degrees should equal 51 plus 68 plus B. So 51 and 68 is 119. So I go 180 minus 119. That should equal B. So 180 minus 119, that is 61 degrees. So B should be 61 degrees. And if I look at this third example, I know that along this line, that's 180 degrees. So D should equal 180 degrees minus 80 degrees. So D is 100 degrees. I know that along this line, that's 180. So angle C should be 180 minus 80. So angle C is also 100 degrees. And I know that it doesn't matter which line I use. I could say along this line is 180. So angle E should be 180 minus angle D. We just figured out angle D is 100 degrees. So angle E is 80 degrees. All right, so we've got all the angle measures there. Which leads us into this concept, opposite angles at a vertex, or vertically opposite angles. Straight lines which cross make an X shape. The point where two lines cross is called the vertex. So this would be called the vertex of this X. In the diagram, P and Q are considered opposite angles at the vertex. R and S are also opposite angles at the vertex. So you can see that P and Q are opposite each other, R and S are opposite each other across that vertex. Class example 1C, right here, shown to the right is an example of a rule involving opposite angles that cross in the form of an X. So we did that one up above. Use a protractor to measure each of the following angles. So let's take our protractor over here and measure each of the following angles. So let's start with angle A. All right, maybe a little larger for you. So angle A looks to be from 0 to 110 degrees, all the way up there. All right, so A seems to be about 110 degrees. Let's now measure angle C. Angle C looks to be about from here to here. That's 70 degrees. All right. Angle C is 70 degrees. Let's now measure angle B. Angle B seems to go from right here to right here, which is also 110. No. Yeah. Also 110. And now let's measure angle D. Which would go from here 2 right there, which is 70. So B was 110, and D is also 70. All right. Do the same thing with ST and UV. So if you have your protractor, you go ahead and try it. I'll do the same thing, see what we get. All right. So I measure that, I get S to be about there to there, about 35. And I will get U, looks to be about, from 0 to there is 145. And I keep going, and let's figure out what angle T is. Angle T seems to be from there to about here. So again, that's 35. And U seems to be from here to about there. So that looks like 145. So we measure them, and it looks like we can complete the following statement. Opposite angles at the vertex. A and B are opposite the vertex. C and D are opposite the vertex. S and T are opposite the vertex. U and V are opposite the vertex. Looks like opposite angles at the vertex are equal. So opposite angles at the vertex are called vertically opposite angles. We use a short term for that, VOA, acronym, vertical opposite angles. The word vertically here refers to the vertex and not the idea of being a vertical line. All right, so the vertex has vertically opposite angles across them, and those angles are equal. Angles around a point. In each case, use a protractor to measure the indicated angles and complete the work. So let's do this real quickly. Let's measure angle E. All right, we expand that out so you can see that better. Angle E seems to be from 0 to 110. Angle F seems to be from 0 to 110. And angle G seems to be from 0 to 140. All right. So E is 110, F was 110, G is 140. Let's try P, Q, M, and N. Same thing. All right, let's start with angle P. So to me, angle P, kind of a tough one, looks to be, let's expand this a little bit, looks to be a little bit greater than 110, so maybe about there. P looks to be about 112. Let's look at M. M, to me, looks to be pretty close to 80. Right there. So M looks to be about 80 degrees. Let's look at Q. Q looks to be about really close to 90. And angle N looks to be 0 to 75, 6, 7, somewhere in here. So it actually works out to be about 78 degrees. All right. So let's add these up. Over in part A, E plus F plus G, 110 plus 110 plus 140. That's 360 degrees. Over here, 80 plus 78 plus 112 plus 90. Well, 78 and 112 is 190. Plus another 90 is 280. Plus 80 is 360 degrees. All right. Based on A conjecture can be made about angles around a point. Looks like they're going to add up to 360 degrees. All right. Example 2 then, calculate the angles marked with the letters. So if I know the angles around a point have to add up to 360, then I know that angle A should equal 360 degrees minus, add up all those ones that are there, 52 plus 57 plus 71 plus 80. All right. So angle A should be 360, subtract, all that adds up to 260. So angle A is 100 degrees. All right. If I look at example 2, again, these angles along this line should add up to 180. And the same is true for the angles along that line should add up to 180. So let's find the measure of angles B and C. All right. Now, we know that for angle B, angles along a straight line add up to 180. So 180 should equal B plus 120. So I subtract 120 from both sides, and 60 degrees would equal B. Okay. Then we do the same thing for A, or C, I guess that is, angle C. 180 would equal C plus 60 plus 55. So 60 and 55 is 115, so 180 minus 115 is equal to C, so 65 degrees equals C. Nice. Investigation of the sum of angles in a triangle then. So once you do this, draw a triangle on a piece of scrap paper and cut it out, just like diagram 1 here. Draw a triangle on a piece of scrap paper, cut out the triangle, then label the angles 1, 2, and 3, and cut off each of those angles. Then place the 3 angles together as shown in diagram 2. Angle 1, 2, 3 placed together. Does the sum of these 3 angles make a straight angle? In other words, can you place them along a straight line? We know the sum of the angles along a straight line is 180. So ask you to do this with a couple different sized triangles, and it doesn't matter what size triangle you use. These 3 angles can always be placed along a straight line, so the sum of those straight line angles should always add up to 180. So the sum of the angles in a triangle, whatever these angles are, it doesn't really matter. Their sum will always be 180. That's a neat little proof for that theorem. How about angles in an isosceles triangle? Recall the following property about an isosceles triangle. There are 2 equal sides and 2 equal angles, and they are always opposite each other. So let's verify this property by measuring the sides and angles of this triangle shown. So go ahead, Get out your protractor and your ruler and measure the sides and angles and make sure that these are both isosceles. So if you measure these angles and sides properly, we'd notice that angle A is 50 degrees, B and C are both equal at 65 degrees. And then side AB is 2.8 and side AC is also 2.8. So those are the two equal sides. Side B should be 2.4. If we look at angles DE and F in the other triangle, we notice that angle E and angle F are both 75 degrees, making an isosceles triangle with the sides DF and DE both being 3.7. All right. So that's by definition isosceles triangles. Two equal sides, two equal angles. Exterior angles of a triangle. In the diagram shown at the right, angle X is called an exterior angle. Angles A and B are called the interior opposite angles. So X is exterior. Here's the exterior angle. A and B are the interior opposite angles. So these two angles are interior and opposite of angle X. All right. C is also interior, but it's right beside, so we don't call that an opposite angle. In the following examples, measure the exterior angle and the interior angles. So go ahead with your protractor and go ahead and measure these angles and see what you come up with. They want you to measure this exterior angle and these two interior angles. All right, they're called the interior opposite angles. This one's called the exterior angle. So in each case, measure the exterior angle and the two opposite interior angles. The exterior angle and the two opposite interior angles. So away you go, pause the video and measure those, record those measurements. Alright, so what we should have came up with, the exterior angle in example 1 is 130. The opposite interior angles are 60 and 70. In example 2, the exterior angle is 70, the opposite interior angles are 25 and 45. And in example 3, the exterior angle is 130, and the opposite interior angles are 30 and 100. So inductive reasoning, we've done 3 examples here. Let's come up with a conjecture or describe any relationship that we see between the exterior angle and the interior opposite angles. Well, the relationship should be this. The exterior angle of a triangle is equal in measure to the sum of the two opposite interior angles. Right. So we can see every case 60 plus 70 adds to 130, 25 plus 45 is 70, 30 plus 100 is 130. That is our relationship. So calculate the angles marked with the letters. The diagrams are not drawn to scale. So here I've got 2 angles inside a triangle. I know the sum of the angles in the triangle is 180 degrees, so that should be x plus 83 plus 65. So 83 plus 65 is 148 degrees. I now minus 148 degrees from both sides of this equation, and I get x. So 180 minus 148 is 32 degrees. All right. Example 2 here with A, B, C, and D. We know that angles along a straight line add up to 180. So angle A should be 180 minus 29. So 180 minus 29 is 151 degrees. We know that angle B is the same idea, angles along a straight line. All right, so angle B should be 180 minus 36. So angle B is going to be 144 degrees. We look at angle C, and I notice that in angle C is part of a right angle triangle because there's a right angle right there. So know that 29 plus 90 plus C have to add up to 180. So angle C should be 180 degrees minus 29 degrees minus 90 degrees. So angle C should be 61 degrees. And finally, angle D is the same idea. Three angles in a triangle have to up to 180. So D should be 180 minus 36 minus 90. So angle D should be 54 degrees. All right. Looking at the two examples down below. Now we can start with whatever angles you want. If I start with the angles here along the bottom of the triangle, I can see that these two angles must add up to 180. So I could say that Q is going to equal 180 minus 111 degrees. So I know that angle Q is going to be 69 degrees. All right. Do the same thing here. I know that P and 128 have to up to 180. So angle P would have to be 180 minus 128. So 180 minus 128 is 52 degrees. So I figured out angle P and Q. I could figure out angle S now, because S is the exterior angle, and these would be our opposite interior angles, P and Q. So I could say that angle S is going to equal P plus Q. S has to equal P plus Q. They're the opposite interior angles. So angle S has to equal P, which is 52, plus Q, which was 69. So angle S should be 121 degrees. All right. What do we have left? Angle T. Again, this is along a straight line. All right. So I know that angle T should equal 180 minus 71. So T should equal 180 degrees minus 71 degrees. So angle T should be 109 degrees. And that just leaves us with angle R. So there's a couple ways to get angle R. I know that three angles in a triangle have to add up to 180. I know two of those already. You could use the sum of the angles of a triangle. You could say that these angles along a straight line add up to 180. So there's a bunch of ways to get angle R. So I'm going to say that angle R should equal the sum of the angles of a triangle are 180 minus P and Q. So P is 52 and Q was 69. So 180 minus 52 minus 69 leaves us with how much? 59 degrees. So there's angle R. All right. Last example. We are told, let's do this one in green. We are told that these two sides are the same length. That means this is an isosceles triangle. Therefore, the angles opposite those two sides must be equal. So angle D has to equal 34 degrees because it's an isosceles triangle. All right? So because of an isosceles triangle, those two angles must be equal. We can now figure out angle E. I know two angles in the triangle. So angle E should be 180 degrees. That's the sum of all the angles in the triangle, minus the two angles we already know. They're both 34. So angle E should be 180 minus 68. That's 112 degrees. All right. And finally, angle F. Well, we could say angle F is an exterior angle, and we know angles that are opposite interior. So F should equal the sum of 34 plus D, and we figured out D was also 34. So F is 34 degrees plus 34 degrees. So F should be 68 degrees. All right. So we found all the marked angles. So in summary, we've used inductive reasoning to suggest some angle relationships. All of the conjectures are true, and some of them will be proved using deductive reasoning. Number one, angles on one side of a straight line add up to 180. Number two, opposite angles at a vertex are equal. They're vertically opposite angles. Angles around a point add up to 360 degrees. The sum of the angles in a triangle is 180 degrees. And the exterior angle of a triangle equals the sum of the interior opposite angles. So a bunch of very important stuff to remember. We're going to have to use that to answer questions 1 through 9. Away you go.